All right, 7th grade, 3.1. You need to go and do your warm-ups. Let me remind you how to get there. Chapter 3, section 3.1, warm-up. Okay, we are doing algebraic expressions today. Your warm-up, find the product. What does product mean? Multiply. Multiplication. And then when it says find the fraction simplest form, what does that mean you need to do?
Simplify.
Reduce it. Yeah, simplify it, reduce it. So when you're multiplying on fractions, how do you multiply?
Across.
Straight across. Very good. This one is negative times a negative, so your answer is going to be a
Positive.
Very good. This one's positive times a negative, your answer is going to be a
Negative.
Good job. Go ahead and do that multiplication. All right, so your key vocabulary talked about like terms and simplest form. Can somebody tell me what a like term is? Izzy?
Terms of the same variable is raised to the same exponent.
So same variable, meaning they both have an x, or they both have a y, or they both have a w, whatever the variable is. And then if anything is raised to an exponent, like x squared, they both have the x squared with them, okay? It could also be numbers with no variables, okay? Those are called constants. So we're going to do example 1. So write this in your journal. Be ready for example 1. I don't know why my video's not working, so this is why you get a little picture of me waving at you.
Hi.
That's all you get.
Is that your avatar?
That is my avatar.
That's cool.
From about 20 years ago when I was skinny.
20 years ago.
All right, here we go.
Say that.
It's rude. There's a picture of me back there. I know you didn't. There's a picture of me back there that... Not right now. All right, here we go. Identify the terms and like terms in each expression. So looking at this, now remember, what's an expression? It has no...
It
has no equal sign.
I was close.
Yeah, you're very close. So an equal sign would make this an equation, equal sign. An expression is just the first portion of it, okay? So, looking at this expression, which terms are like terms? Joaquin.
The x and x.
The 9x and the negative x.
Oh.
Okay? So we're going to rewrite this. We have... Oh, you don't have to do that. Okay, the 9x and the negative x would be considered like terms. What are the other like terms here? Good. The ones without a variable.
Yes.
So the negative 2 and 7 would be like terms. Gentle. So 9x and negative x are like terms. And then negative 2 and 7 are like terms. You don't have to write this middle one, guys. The sum of terms. I just want this down here. Like terms.
Oh.
No. If you wrote it, that's fine. But it's going to confuse you. So just skip. So let's do this other side. For B. So, somebody raise their hand and tell me which two of these would be considered a like term. Elliot?
Oh, wait.
Go for it.
Z to the power of 2 and 3z to the power of 2.
So this z to the power of 2 and 3z. Okay, you're missing one little, poor tiny little...
3. Negative.
Negative 3. Yeah, make sure you keep the sign with the term. So z squared and negative 3z squared would be considered like terms. See the blue? Okay, so z squared and negative 3z squared. And then what's our other pair of like terms? Joaquin? We said the z squared and the 3z squared, negative 3. What is the other pair of like terms?
This is so hard.
It's very difficult.
5z and z.
5z and z is correct.
He's so smart.
Shh, he's very smart.
He's the smartest kid on the
Okay, any questions about what a like term is?
very easy.
It is, but if you have a question, that's fine. Go ahead, what's your question? Okay, these are like terms because they both have a z variable and they both have an exponent of 2. These are like terms because they both have a z variable. What exponent are these technically to? The power of what? No, that's what these are. What is this one technically to?
1.
It's to the power of 1. Okay? You are very smart.
But
All
don't
right.
add an
Okay.
exponent.
No, don't write it on there. Just
Nobody
testing you.
puts to the power of 1.
no, because it's a waste of your time. All right, good. Go do your try-its. I'll leave it up. I'll leave it up. Okay, you're doing try-its. I can't see it.
1 to 3.
1 to 3. There it is. Try-its 1 to 3. Go ahead.
Okay.
An algebraic expression in simplest form when it has no like terms and no parentheses is an algebraic expression. So once you've simplified and combined all the like terms and distributed all the different parts, this is called simplest form. Okay? To combine like terms that have variables, you do distributive property to add or subtract the coefficients. So let's practice this. So in your journals, example 3, 2? 2. Example 2. So we're going to simplify this expression. Are these two considered like terms?
Yeah.
Why?
They have
They both have an N at the end.
They both have an N, just chilling. So I can essentially distribute so that the N is by itself and I just do the coefficients. The coefficients is the number on the outside, the number hanging on to the letter. So let me show you how you would rewrite this. You would distribute you would take the N out of there. So it's almost like dividing the N away. See how they pull the N out and you just have the coefficients? Because if I went backwards and I go N times 6 and N times -10, you get this, right?
I get it. No way. I get it.
This is reverse distribution. Okay?
My brain's so gone.
This is okay. So once I've pulled the N out to where the N's on the outside of the parentheses, now I can just simplify what's on the inside, right? What's 6 minus 10?
Negative 4.
-4. And then times N.
I just gained my whole brain cell.
You did. Congratulations. It is very important you understand this backwards distribution.
I just
Okay? Yes, Joaquin.
Isn't there supposed to be 2 N's?
No, because we pulled it out. See how there's an N here and an N here? We pulled it out so that way we just did the coefficient.
No, but like 2 N's outside.
No, because if I redistribute it, if I take this N times 6, N times 10, then it becomes this. Okay, another way to look at this, guys, listen, is when I have 6N minus 10N, all I'm doing is subtracting or adding the coefficients. So I don't have to undistribute it if you can, in your head, think of it this way. I can go, okay, the N's are the same terms, so I just need to go 6 minus 10, -4N. It's like saying I have 6 N's to begin with. I'm going to subtract 10 N's. How many do I have left? Well, I have -4 N's. Does that help?
Yes.
Okay, so let's do the second one. First thing you need to do is simplify this. Okay, are they all like terms? Yes, because they all have a W that has not got any extra exponents. What's in front of this imaginary W right here?
Nothing.
1.
There's nothing written there, but what's an imaginary thing in front of it? 1. All letters have an imaginary 1 in front of it, so you see it right here. Okay, if it's just chilling by itself, it has a 1. That way you know you're adding it. There's 1 W there. Okay, so now that we have that, can we combine all of these terms?
Yeah.
Yes. I could undistribute the W, right? Right now it's distributed within all 3 of these numbers, yes? So if I pull it out and put the other 3 in the parentheses, then I've undistributed a W. And I have -8.5 plus 5.2 plus 1. So that's just the coefficients you see, right?
Yeah.
Good. Now we can do this arithmetic, yes?
Yes, what?
This is arithmetic when you're adding and subtracting. It's just, arithmetic is the easiest math. So what is -8.5 plus 5.2 plus 1?
-2.5 W.
Close. Yeah, no, 2.3. Because this is 5 point... Yeah, you were close. Okay? So you have negative 8.5 plus 5.2 plus 1. So my brain does this in my head. I add the 1 to the 5, which makes this 6.2. And I go, what's 8 minus 6? 2. 5 minus 2, 3. So that's how my brain does it.
Wow.
So negative 2.3W because the biggest number was a negative. Any questions on how we did this? This is very important you understand this. So if you have a question, please ask it. Good. All right. Go do your try-its.
3, 2, 1, go.
No, wait.
4 through 6, and then we'll do another example. So we're going to simplify. This is example 3 in your journals.
Yes. Oh, yes.
Okay, we're going to simplify. So looking at this expression, which ones are like terms? Joel?
The 3/4 y and the negative 1/2.
The 3/4 y and the negative 1/2 y. What is the other set of like terms, Joaquin?
12 and 6.
Negative 6. Don't forget the negative.
How was the negative?
It's got to stay with it.
I thought that was minus.
When you're moving the terms apart, that minus attaches to the number behind it, and it's called a negative. Okay, so if we rearrange this, it would make it simpler, right?
Yes.
If I did 3/4 y, and you can write this as plus negative 1/2, or you could just say minus 1/2 y. Man, got something it's hurting. Okay, and then I would have plus 12, and you could just say minus 6. You don't have to say plus minus 6. Okay, now can I combine these?
Yes.
Yes. So you would do 3/4 minus 1/2. What's 3/4 minus 1/2?
1/4.
No.
Y. He's right. 1/4 y. I was just saying 1/4 y. You just got the end of it. Not y. You got the answer. Okay, and then what's 12 minus 6?
6.
6.
Yes.
So then this is my final answer. I combined the like terms with the y, get 1/4 y. And then I combined the terms that don't have an exponent, that don't have a variable, to get 6. Question?
So since you're subtracting it, you flip the 2 and the half.
Here?
Yeah.
So you have 3/4 minus 1/2. So you got to make a common denominator. What's the common denominator between 4 and 2? 4. So this would be like 2 over 4. So what's 3 minus 2?
3 minus 2 is
1. And then the bottom would be 4. Make sense? Do you want me to write it? Okay. Give me 1 second to get my whiteboard. If I have 3/4, it's a terrible 4, but whatever. 4. There we go. Y minus 1/2 y, right? Okay, and then after that we have plus 12 minus 6. Good so far?
Yeah.
Okay, so in order to combine the y's, I have to get a common denominator. Common denominator between 4 and 2 is 4. So I just rewrite this, 3/4 y. That's the better 4. Minus, okay, what times 2 gives me 4?
2.
2, so that makes 4 on the bottom. 2 times 1 is 2. And then y. So now I can say 3/4 minus 2/4.
Oh.
What is 3 minus 2?
1.
1. The bottom just stays the same when you're doing subtraction. The denominator. And then y. So now I do this half. What is positive 12 minus 6?
6.
Positive 6. So then I just say plus 6. Yeah, if you guys ever need me to write it just so you can have the visual, please tell me. I am happy to do it.
Okay.
My number.
All right, let's talk about B. Okay, are you writing this in your journal?
Yes.
All right. So you have negative 3y minus 5y plus 4z plus 9z. Which ones are like terms, Ricky?
Negative 3y and 5y.
Yes, negative 3y and negative 5y would be one set of like terms. And then the other set?
4z and
Very good. 4z and 9z. So now I can just do the y stuff first. I can undistribute it like they did here. What's negative 3 minus 5?
Negative 3 minus 5 is
8.
2.
Negative.
-2.
Go further negative.
8.
Oh.
So it'd be negative 8. And then what's 4 plus 9?
5.
13.
13.
13. And then you just tack the z on top. Okay? Now, if this is difficult for you, if looking at the undistributed version is hard, then just go over here and say, well, what's negative 3 minus 5, and put the y on the back of it. That's fine too. The undistribute is really important for you to learn, but we can work on that. All right, so let me go over number 7 with you to refresh you. So we're looking at this, and we're going to say, what is a like term here? So which ones are like terms? Camille?
Like terms of it, it's 14 and 8.
14 and 8 would be considered a like term. That's right. So you could go ahead and add, what is 14 plus 8? Let me get my little whiteboard.
22.
Yes. New page. Bless you. Bless you. 14 minus 3z plus 8 plus z. Let me write this down. 14 minus 3z. Help me out. Whoa, that's a fantastic 3.
I love that.
3z plus 8.
Yeah.
And then what's the last?
Plus Z.
Plus z. I always just have one number that goes haywire, right? All right. So we have decided that the 14 and the 8 are like terms. So what is 14 plus 8?
22.
So I'm going to say plus 22 here at the back. Okay, because I've already added those. So then what are the other two like terms?
3z and z.
The negative 3z
Oh,
and then the positive z.
that's a negative.
Okay, what's in... Whenever this is a sign, you got to attach the sign to the coefficient following it.
And it's z. Oh, never mind.
Because the 14 was positive. Okay, what imaginary number is in front of z here? 1.
No.
So I'm going to say negative 3 plus 1.
Negative 2.
Is he correct?
Yeah.
Z.
Negative 2
Z.
z. So then your simplified expression would be negative 2z plus 22. Does that help?
Yes.
Good. Okay, so there's the answer to number 7. You should all type that in. You need to do this, not just eat. It's okay. Any other questions on this? Okay, so this is your last example 4 question mark? I think it's 4. Okay. If you haven't finished your triads and self-assessments, that's just due tomorrow. You have time later.
2 more questions.
Okay, good. All right, so each person in a group buys an evening ticket, a medium drink, and a large popcorn. How much does the group pay when there are 5 people in the group? So the first thing we need to do is figure out, what are they asking here? What do they want us to do? So we're going to create a verbal model. Okay? Verbal model is the math in words. That's what a verbal model is. So the first thing we need to put is, we're going to multiply the number of tickets times the cost per ticket plus the medium drink times the cost per the medium drink plus the large popcorns times the cost of the large popcorn. Does this make sense?
Yes.
When y'all go to the movies, this is what y'all do. You don't even realize you do it. You go, how many people are there? Okay, that's 6 people. The ticket costs $7.50. 8th grade. Samuel, stop talking. And then you think, okay, let's get drinks, popcorn, and you guys do this unconsciously. We're going to do it on paper now. So now that you have a verbal model, we can translate this into an algebraic model. Question?
Do we have to write that?
Not yet. I'll tell you. Okay, so this is, we're just taking this verbal model, and we're going to plug in variables. So how many tickets are we buying?
5.
So we're going to write a number 5. Why is there $7.50?
Oh,
Because that's how much it costs.
Oh, we don't know how many tickets. That's right.
We don't?
I mean, we do, but we don't yet.
Oh.
I apologize. So we're writing the cost on here. The cost of a ticket is how much?
$7.50.
$7.50.
Yeah, $7.50 right here. Evening tickets, $7.50. Okay? Times X, which is the number of people. Right? Yes, we do know the number of people, but that's for at the end. Okay, and then how much were the drinks?
275.
Yep, you can look over here. We got medium drinks, so medium drinks, 275 times the number of people, which is what X stands for. Okay, and then the last one, Josh, stop talking, is a large popcorn. Costs how much? $4, right here. 4 times the number of people.
5.
Right now it's X. Okay, have we created an expression now?
Yeah.
Yes.
Can we simplify this expression?
Yes.
Why can we simplify it?
Because yes.
They all have the same. They're all
They all have
like
the
terms.
same.
They're all like terms. Very good. They all have just the X. There's not an X squared or anything. They're all considered the same. So we can actually add the 750 plus the 275 plus the $4. You can see here it's undistributed, so you can add those 3 terms up. Somebody tell me, what is 750 plus 275 plus 4?
E 10. I can't add today.
Yes, you can. I believe.
What?
275 plus 4.
1325.
It's 10.
So close. 1425. 750 plus 275 would be 7, 8, 9, 10, 25 plus 4. You missed the plus 4. That's why you got that. Okay, so that's 1425 per person. Because I got a ticket, I got a drink, and I got a popcorn. So each person's going to cost me $14.25. Now, how many people are there?
5.
So we're going to plug that in where X is and say $14.25 times 5, which is, Sam? $71.25. Y'all need to thank your parents when they take you to the movie and buy you all these things. Because this is...
We sneak it in.
Well, I do the same, but I'm just saying. When they buy the tickets, this is what it costs. Shh. They don't care. All right, any questions on, first, how did we make this equation or how we simplified it? Any questions? Is this a question? Okay, I'll go back. Any other questions? Good? Okay. Finish through the self-assessment. It is due tomorrow. You may have a few minutes after lunch, but you have 9 minutes remaining until we go to lunch. So work on it right now. Question. Okay, so this is number 16, 7th grade, to help you with it. An exercise mat is 3.3 times as long as it is wide. Write expressions in simplest form that represent the perimeter and the area of the exercise mat. Use the variable W to represent the mat. Okay. Where is my whiteboard? Move my face. That's not really there. Okay, so new page. Why does what look like what? Because I made it pretty. You can put borders on it. And my face is gone because the camera's not working, so at least I got a emoji. Alright, 3.3 times as long as wide. Okay, so 3.3, where's my marker? 3.3. Okay, if you're not going to pay attention, I'm not going to do this. If you want my help, fine. Okay, 3.3 times what? As long as it is wide. So 3.3 times as long as it, I have to think. As long as it is wide. So 3.3 times W equals the length.
Wouldn't that be 3.3?
I'm thinking, hold on. 3.3 times as long as it is wide. Ooh. Uno momento. Okay, so we talked about how we set this up, okay? And it told you, sorry, I paused and came back. It told you that it is 3.3 times as long as it is wide. Okay, so the length, see the L here? The length is 3.3 times the width. All right, everybody understand that? How I got that? Okay, so now you need to discuss what is the perimeter. What is the formula for perimeter? Close. Length plus width, but if this is if this is 4 sides, it's 2 lengths plus 2 W's. Think of a square or a rectangle. Right? If I want to know the perimeter, the outside, I have the width here, the length, and the length. So I have 2 L's and 2 W's, and that gives me the perimeter. Make sense?
Okay.
So this is the equation that they want you to solve, knowing that L equals this. That makes sense so far? So you're going to plug that in where the L is. So if I rewrite this, I have 2, wow, that was a crazy 2, times,
2 has lost its mind.
it did, 3.3W, this is algebra, guys, plus 2 W's. So far, so good?
Yeah.
I might write this down as an example in your journals, by the way, so you have this for future. So what is 2 times 3.3?
6, no, 6.
To what?
2 times 3.3.
6.
Isn't it just 6.6?
Yeah.
6.6, yeah.
Okay, plus 2W. Are these like terms?
Yes.
So add them. What do you get?
8.
8.6.
So the perimeter is 8.6 W. Okay? An expression. They may want this is the answer or this is the answer. I don't know which. They probably want this one.
Try them both.
I can go look and see what they put. Oh, yeah, you can just put the answer. I lost my whiteboard. So you can put this as the answer.
Put them both. No,
It's wrong?
The second one.
Then-
6.6W.
Yeah, that's what I said. Just put this one.
The expression for the area is the
8.6 W. No, this is perimeter.
Oh,
We haven't done area yet. We just did perimeter. Area is a different formula. We'll do that in just a second. So this is just perimeter. P equals 8.6 W. Does that make sense?
Yeah.
All right. Now I'm going to do the area. Okay, remember this. L equals 3.3 W because we're going to put that on the next one. Okay, so we know length equals 3.3 W. Okay, again, you have your rectangle. How do you find the area of a rectangle? Times what? Length times width. So area is length times width, right?
Yeah.
Okay, well, what is what can we substitute for L here? 3.3 can go right where that L is. So we rewrite this saying A equals 3.3 W. Man, it's so slow to write with the mouse. Times W. Okay? Now, this is multiplication here. Okay? If I have W times W, what do you get?
1.
1.
Oh,
No,
no,
W.
1.
No, it's W times W. Okay, look here. If I do 2,
W.
let me give you a hint. If I do 2 times 2, you know that it's 4, right?
Yeah.
Is that the same thing as saying 2 squared?
No. Yes.
Yes.
Yes. 2 squared is just 2 times 2.
Just in a different.
Okay? So then if I do W times W,
It's W.
it would be W squared. The only catch is you have to put this because you do the 3.3 times what's in front of this W? An imaginary 1?
Yeah.
What's 3.3 times 1?
3.3.
It's just 3.3. So then the area is 3.3 W squared.
Yes.
Comprende?
Comprende.
Any questions? Yes.
So whenever you do that, you have to put the 2 above the W.
W squared.
You're adding the W.
You're multiplying. This is multiplication.
So whenever you multiply.
Whenever you multiply, see this is the dot, so it means multiplication. We can't put an X for multiplication anymore because we have variables that are X's. So now the dot means multiplication. So whenever you're multiplying variables, letters, it becomes the letter squared. If I did 3 of them, if I had W times W times W, that's going to be W cubed.
Okay.
Make sense?
And can I help number 2?
Number 2?
17.
Number 17?
Oh,
This one. Yes? Okay. So we'll do this last one.
Okay.
All right, so a group visits a movie theater. Oh, this is like our example.
Yeah.
Each person buys a daytime ticket and a small drink, and then they share 2 large popcorns. What is the average cost per person when there are 4 people in the group? Okay, so it's similar except for they're sharing the popcorns. So instead of buying 4 popcorns, I'm only buying 2. So we need to find out what the total cost is and then divide it by the number of people that are at the movie. Right? Because they want to know the average cost per person. I think I just answered his question. All right, let me grab my whiteboard. Did you get it right?
Yeah.
Good.
Wait, what?
Do more people want me to do it? Or do you want to try it?
C.
Do it? Okay. So, daytime ticket. How much is a daytime ticket?
$5.
$5. $5 times the number of people, X. Plus, then what do we buy? A small drink. Everybody got a small drink. What's my cost of a small drink?
$1.75.
$1.75
Yeah.
times the number of people. Okay? And then we bought what? 2
Popcorns.
large popcorns. So it's not times the number of people, it's just 2 large popcorns. What's 1 popcorn cost?
$4.
So what would 2 popcorns cost?
$8.
So I can just say plus 8. Now can I simplify this expression?
Yeah.
I can add these 2, right?
Yeah.
What's 5 plus $1.75?
$6.75.
$6.75 X, don't forget the X, plus 8. Okay, so now my expression is simplified. Can I find out how much money we spent?
Yeah.
How many people came?
4.
4.
So I can plug in a 4 here. So what is 675 times 4?
27.
Plus 8
35.
equals 35. Okay, the question asked, what is the average cost per person? So if I paid for all this and then had you guys Venmo me what you owed me, I would take the total amount of money I spent and divide it by how many people showed up.
Oh,
So what is 35 divided by 4?
8.75.
So each person is going to Venmo me $8.75.
Not bad.
Why not PayPal?
I already got it right.
Because Venmo's faster.
What about Zelle?
I don't have Zelle. I'm old.
That's a seal.
Okay, any other questions?
That's what?
All right, that must be done. All right. Make sure this is done by tomorrow. Well, that was the last question, so you guys are done with your homework. Woohoo, you're welcome.